And welcome back. We're here with episode 4 of AWS What's Next. I'm joined by my host Rob Zhu, and my name's Nick Walsh. We're two developer advocates here at Amazon Web Services. We've got
Twitch.
Yeah, hello Twitch, LinkedIn. We're streaming live to quite a few platforms here. Again, let's emphasize this is a live show, so if you have at any point in the broadcast any comments, questions for our service team members or for Rob and I, please get those in chat. But Rob, I mentioned we're here, episode 4 of What's Next. We clearly haven't been canceled yet. We must be doing something right. For anyone who's tuning in for the first time, can you tell them a little bit about what we do here on this show?
Yeah, absolutely. So we have a lot of service features launching all the time across AWS. It's kind of hard to keep track of it all. We have a couple resources to help you out. One of them is our news blog, and there you can follow along and see a list of detailed launches and the corresponding articles. We also like to pick out a couple of those and dive deep. And when we do that, we can also invite members from the service teams that built these services to kind of have an in-depth conversation, give us a demo, and tell us about the service from their perspective.
Yeah, and we know that some of these launches make their way sort of to the forefront in the form of talks at some of our major summits, at reInvent. But we also know that a lot of these demos, a lot of these really powerful functionalities are available out of the gate here. And so with this show, we wanted to be able to find a way to sort of provide a platform for all of the AWS users at home to actually get a sense of what it means to actually use some of these features and not have to wait around for the next nearest summit or hands-on demo to be produced, because a lot of those already exist. So again, we've got an action-packed lineup today. I mentioned it before. I won't keep you all waiting in suspense. We have 4 separate demos that we're doing today, trying out a bit of a different format. We are going to have Graviton 2 and the new M6G EC2 instances. Then we will be joined to see a little bit about the latest launch from AWS Glue for streaming ETL. Then we have the GA launch of Amazon A2I, Amazon Augmented AI, something I'm really excited about. And then lastly, another one that I know lots of folks have been waiting for is the launch of Amazon Kendra, enterprise-grade search. So 4 very, very exciting demos. Again, joining us are going to be each of the respective service teams. Rob, which one are you looking most forward to?
Oh, those are all so exciting. It's very hard for me to pick. As somebody who built their own PC for many years, I'm kind of a hardware geek, so I really like the Graviton 2 deep dive. I'm really looking forward to that. We have an awesome guest for that segment, but I'm also very excited about Kendra. I think this is, I've spent my fair share of time fruitlessly searching for answers on various corporate, search portals, and I think Kendra can really make that better for everyone. So I'm really looking forward to that as well. Kind of a cop-out answer. I have 2 favorites today. But I mean, four demos in one episode. We haven't done this before. Episode 4 demos. Does that mean episode 5 demos?
Oh God, this is going to be a slippery slope here, Rob. I mean, episode 1 had 1 demo, so I'm sensing a trend here, even if it's not deliberate.
It's the beginning of a trend.
We're just going to be approaching 24-hour streams before we know it. We're just going to be hooked up here in front of the webcam all day as the real-time live feed of launches.
Exactly.
Yeah, other weeks, Rob, you and I have sort of gone through some of our exciting launches, but again, one of the unique parts about this show, we get to dive deep, we get to see demos, we get to sort of platform these service teams that make these amazing features. So we won't waste any more of your time. Again, thank you for joining us. First up, as I mentioned before, we're going to be talking to the Graviton 2 team members from the Graviton 2 team that were launching the new M6G instance classes. So stick around. We're going to be right back with the first guest. So don't leave. We'll be right back. All right, I promised we'd be back very quickly, and here we are. I don't know how many seconds it was, but it was less than 30. So for all you counting at home, +1 for us. Okay, cool. So I mentioned first we're talking about Graviton 2 and the new M6G EC2 instance classes. Here to tell us a little bit more about that is Sudhir Raman, Principal Product Manager for EC2. Sudhir, thank you for joining us today.
Hi, thank you for having me.
Okay, so obviously a very, very exciting launch. I know we have a very large number of EC2 instance types. It can be sometimes confusing to wrap our head around all of them, but let's start a little bit with Graviton 2, which is what's going to be making these new instances very, very unique, so to say. Can you tell us a little bit about, at a high glance, what we're launching today with Graviton 2?
Sure, yeah. So we are actually launching our next generation EC2 general purpose instance. So across our EC2 portfolio, we have a large number of instances to serve pretty much every single workload that our customers run in the cloud. And this particular focus today is on the general purpose instance family. And by that, we mean essentially a broad spectrum of workloads like containerized microservices, be it web tier, mid-sized databases, caching fleets, and things of that nature. And we are specifically talking about the M6G instance, which is our next generation general purpose instance powered by the AWS Graviton2 processors. And what these instances do for our customers is they can enable up to 40% price performance benefits versus our previous generation M5 instance.
I mean, yeah, and I understand that this is a custom chip. Is that correct?
Yes, absolutely. So this is an in-house AWS designed custom chip that we've, as AWS, partnered with Annapurna Labs, a company that Amazon acquired a few years ago. And this is a company that we've partnered with to deliver many custom silicon initiatives. Some of those in the past have been the building blocks and the offload cards as part of the AWS Nitro system that essentially increases the overall resource efficiency on an EC2 instance type, and also the AWS inferential chip that we released back in 2019. So we've collaborated with that team. We've now introduced our next generation Graviton2 processor built using 64-bit ARM Neoverse cores.
Can we just take a second to actually appreciate that to the extent in which I think we should? A custom chip, right? Like, this is something that's pretty monumental. We obviously didn't make this decision lightly. Is there any particular set of reasons why we created our own chips? I know obviously we created some unique value there, but typically we think of creating new things as a purpose-built solution to a problem. Can we walk through some of those?
Yeah, absolutely. I think that's a great question. So as part of our workload optimization journey, we've invested in many custom chip initiatives so that we can build targeted optimizations for cloud native workloads, also based on our extensive knowledge of running cloud workloads at scale. So in the past, I touched on the Nitro system. We built custom chips where essentially we build dedicated cards that can offload some of our networking and elastic block store functionalities so that the host processor essentially gets all the resources that we can deliver back to a customer. As part of that journey, we've continued to innovate at various levels of our infrastructure. And using our own CPUs, we are now able to deliver essentially optimized cost and performance points for our instance types. That essentially translates into a significant price performance benefit for our customers. And one other major benefit here is that we're also able to build, innovate, and iterate directly on behalf of our customers based on direct customer feedback. And finally, with now bringing the ARM architecture into the cloud, we're also able to expand the selection of compute choices and architectures for our customers.
Wonderful. So deeper efficiencies from deeper vertical integration in our own infrastructure, always really exciting to see. So going back, again, you said that the new instance, the M6G, is again general purpose compute, right? And there's lots of different types of EC2 instances I mentioned before. What does the M instance class sort of mean, and what are other instance types that are available for folks that may not have looked into that?
Sure. Yeah. So the M instance class is basically, multi-purpose, general purpose. So this is sort of for your broad set of, the classic, the web tiers and the microservices and the caching fleet kind of workloads that you can run. A majority of our customers, count on these core M instance types for a large portion of their workloads. And the other instance types that we have within our EC2 families, we essentially have these categorized by the workloads and the optimizations that we built for these instance types for a specific category of workloads. An example would be the compute optimized C instance type that is targeted for workloads that are more sensitive to single-threaded compute performance, for example, say a gaming server or a high-performance computing workload. Another class of instance we have is the memory optimized R instance types that are targeted more at larger databases, in-memory workloads that are more sensitive to memory, both capacity and memory performance.
See, I've always thought that it would make more sense to have the M class instance be the memory optimized instance, but just got to do a little translation every time I'm looking up the pricing chart for EC2.
Yeah, that's an interesting viewpoint. I think
I'm sure you get that a lot.
There's a multi-purpose part of it, and then the RAM part of it, which is the R, which
oh yeah,
kind
of
gets
course.
into the memory optimized as well.
So now the other important thing about this announcement is that this is the M6G, right? This is the 6th gen instance. I haven't seen any other 6th gen EC2 instances. Is this the first 6th gen EC2 instance?
Yep, that's correct. So this is the first 6th gen EC2 instance that's now generally available. What we've also announced are corresponding 6th gen EC2 instances that are powered by Graviton2 CPUs again, as part of our compute optimized C family, which will be the C6G instance. And we will also have it part of our memory optimized R family, which is the R6G instance. And both of those instance types will be available in the coming months.
I just want to pause there for a second. I think this is very significant. EC2 is one of the most heavily used services on AWS. Lots of customers depend on EC2 every day for their workloads. And what we're doing here is we think that the performance and price improvements here are significant enough to designate this as a brand new generation of EC2 offering. I feel like we should have had a bottle of champagne ready for this, Nick.
I mean, there's so many causes for celebration, right? New regions, new EC2 instances. We'd need a sponsorship at that point, but
yeah. But can we elaborate on that a little bit? You know, what does a generational improvement mean? I mean, when we see something like an M5 or an M6, what should customers expect?
Yeah, one of our key tenets as we go through a generational improvement is we want to provide compelling value for something that meets the bar of a generational refresh. And a lot of times our customers value, essentially the price performance benefit that you get from going from one generation to the other. But it doesn't just end there. There's also other benefits that we've typically brought in terms of enhanced capabilities, just pure performance across different dimensions, be it compute networking or EBS. So when you put all of this together, that really is what qualifies as a next generation improvement in an instance. And in this case, with the M6G, with a 40% price performance benefit, we feel that's a significant leap going from Gen 5 to Gen 6.
Very exciting. Do we want to dive a little bit deeper on sort of like the architecture, the chipset for Graviton2 and how this sort of powers these improvements that we see under the hood?
Yeah, absolutely. I think happy to share some of those details in terms of taking a closer look at the Graviton2 processor and lifting the lid a little bit. Let me share some supporting slides as we walk through some of the deeper features here. And please let me know when this comes through.
Yeah. Yeah, it looks good to me.
Yep, I can see that on my end.
Okay, awesome. So what you see on the left side of your screen is our first generation Graviton processor that we announced back in re:Invent 2018. It was built on the 16 nanometer process technology, 5 billion transistors, and it was the first, essentially the ARM instance inside AWS and also as part of a major cloud. So it enabled the ARM architecture to be a first-class citizen in EC2, and it also enabled a certain class of workloads called scale-out workloads, where a lot of our customers have been able to transition to the first generation Graviton and take advantage of the cost benefits. Now, what you see on the right side is Graviton2 that is powering our newest M6G instance, and this is a completely different beast. So this brings in an order of magnitude improvement in terms of performance and capabilities, right? And the pictures are actually to scale. So you can actually see that the Graviton2 CPU is much larger, just in terms of pure size. And as it packs 30 billion transistors, and it's built on the latest generation 7 nanometer manufacturing technology.
You know, Sudhir, from looking at these specs, it almost seems like Moore's law is alive and well.
Yeah, absolutely. I think one of the biggest things that we've been able to achieve through our partnership, where we've worked with ARM to essentially shape the N1 core, is the performance improvements that we're able to deliver here. So going from our previous gen to the Graviton2, it's on a per vCPU basis, almost 2x performance improvement. And an aggregate with 4x the number of cores from Graviton 1 to 2, that's a 7x performance improvement on an aggregate CPU level. And I just want to dive a little bit deeper as we lift the lid and look into the cores as well. So like I said, we've integrated 64-bit ARM Neoverse N1 class cores. And along with that, there's a lot of the custom silicon design that AWS has built and integrated. And the CPU itself delivers a number of caches, a significantly large cache. So both L1 and L2 caches. There are a lot of optimizations built in that essentially lowers the overheads of some of our virtualization and context switching. And we also have additional instruction support for specific workloads. For example, if you can look at the N8 and the FP16, that's built into the CPU as separate instructions that you can use to accelerate, say, a machine learning inference application. And there's also dual SIMD units that essentially help to deliver improved floating point performance. So great for a lot of the encoding workloads, HPC kind of class workloads as well. And a significant point to note here is that each vCPU that we vend here in an M6G instance or Graviton 2 CPU is actually a full physical core. So we don't have simultaneous multi-threading, which actually means that you can actually vend out a full core with dedicated caches, more isolation back to our customers as part of a vCPU. And also the interconnect when it comes to how all these different cores are communicating with each other. So we have 64 cores in a Graviton 2 CPU connected together in a mesh, significant amount of bisection bandwidth up to 2 terabytes per second that allows them to communicate with each other very quickly. And then as with a single core without multi-threading, and also because it's a single socket, so you actually don't have any NUMA concerns. So every core is actually seeing the same latency and a path to the memory. And a lot of IOs, plenty of PCI Gen 4 to give us the flexibility in terms of connectivity and enabling multiple instance configurations. And finally, on the memory side, a couple of key features to call out. So to feed all these cores, we want to make sure that the memory bandwidth keeps up. So we have 8 channels of DDR4 running at the highest speeds of 3200. And this is also improving our overall security posture here because we have always on 256-bit encrypted memory that's supported with our Graviton 2 CPUs and the M6G instances.
You know, I would like to boast that I overclocked my own computer's RAM to above 3200 megahertz, but I don't think AWS would let me anywhere near the data center to mess with these Graviton 2 chips. So we'll leave that to those experts. But some really amazing advancements here. There are some folks asking in Twitch chat, you know, so what does this look like for actually getting to use this value as far as a consumer product in the M6G instance class? What are the exact instance sizes that are now available to consumers as part of this GA launch?
Yeah, absolutely. I have some of these sizes over here, and I'll quickly summarize. So basically, it's we start from a medium instance size. So one of the benefits of being able to deliver a full core is that with better isolation, we can now offer a medium instance size, which we were not able to offer with an M5 instance. So it starts with 1 vCPU. And across the board, what you're going to see is you will see 4 GB of DRAM per vCPU. That's the ratio we have for a standard M instance type. So we go from a medium with 1 vCPU and 4 GB of DRAM all the way to a 16 extra large that has 64 vCPUs and 256 gig of DRAM. All of them come with enhanced networking support. So we go up to 25 gigabits per second of networking bandwidth. We also have EBS supported. So there's EBS optimized burst. Going up to 19 gigabits per second of EBS bandwidth. And yeah, so that's basically the full set of instances. What I also don't show here, which we support as part of the launch, is also a bare metal version. So it's not just the verts, but we also have a bare metal version of M6G that's currently available.
Yeah, I know. I think another interpretation of the questions going on in Twitch is this a product? So this is a question from Denny1111. Is this a customer product, or is this used only by AWS? I think what he means is, can I go to Best Buy and pick up one of these chips?
No. So the short answer is no. This is part of our infrastructure. It's currently within the EC2 infrastructure.
That's too bad. I imagine, bring a couple of these home and tinkering with them would be pretty fun.
I imagine a long answer that's like, if you subscribe to an AWS magazine, I can mail in and get one delivered to my house. But unfortunately, I
Right.
don't think that's the case either.
Right. So, okay, so and again, as a reminder, I mean, these are all under the instance tag. They all begin with M6G, so these are all using the Graviton2 processor, which is an ARM processor, and that raises the question: are we going to see non-ARM based EC2 instances under the 6th gen tag?
Yes, so we will plan to introduce both Intel and AMD based 6th generation instances over time, and we don't have a specific timeline to share yet, but yes, we should fully expect that we'll continue to offer multiple choices within every generation.
Great to hear. We talked before about sort of the benchmark number around, 20% lower cost versus M5 or 40% savings on particular workloads. Do we have any specific benchmarks or other workloads that we can cite that Graviton2 and M6G instances will improve?
Yeah, absolutely. So I have a few different benchmarks over here that we can talk through. So spec tends to be pretty much a conversation starter when we're talking about CPU performance. So what you see here is I'm going to show you a few different benchmarks and workloads that we've tried out. And there's also some customer examples because we ran an extensive M6G preview program, and we got a lot of customers to actually test it out and provide feedback as well. So the summary is that across the board, in the number of workloads that we've tried, we've seen anywhere between 20 to 45% higher performance per vCPU on M6G compared to M5. Some examples here is you're looking at spec CPU based on 2017. You can see here it's a little more than 40% performance improvement. And on a spec FP, the floating point performance, we are seeing a little over 20%. Some other workload level examples. So here is Memcache D workload. So we gave this a try where we had a load generator through coming from some of the C5 instances that then essentially connect to a Memcache D that's running on M6G versus M5. And here again, the number of requests per second that you see is pretty much significantly over the 20% mark. And it's not just the number of requests per second. The other part to note here is the latency. Right? So you can also see that the latency of serving these requests is also significantly lower when you look at the M6G versus M5. Again, media encoding. We've tried here, a lot of video being created every day. We need some of the media encoding part to overall reduce the bandwidth and store it. So here again, with H.264 encoding, we've seen a significantly higher performance with M6G. And I'll just walk through a couple of other examples. We also tried an EDA workload. As you know, chip design can be super complex, so a lot of cycles are spent in doing simulation to model the chip to make sure that things look okay, because going back and fixing a chip can be super expensive. So here we took an example of an EDA workload with Cadence running on an ARM processor, simulating the ARM CPU itself. And again, the performance per vCPU that we saw here, and the point to note is we're comparing an M5 24 extra large with an M6G 16 extra large. So significantly smaller sized, but also a performance improvement that we see here overall. I'm going to switch to some examples from customers who have tried M6G as part of their preview. And here's what they observe, right? So here's an example of EQ Alpha that benchmarked the KeyDB as a database workload. And what they saw is upfront when they compared the large, extra large, the medium type instances, up to 65% better performance on the KeyDB workload than M6G. Here's another feedback that we got from Honeycomb. As they compared their existing fleet of C5 instances, they tested it out, replacing them with M6G, and found that they can actually use now 30% fewer instance types. So that's in a nutshell some of the different benchmarks and some of the early feedback that we have from customers. We also have our M6G webpage where we published more customer stories as part of the preview program. So definitely encourage folks to go take a look at that when they get a moment.
Okay, Sudhir, I think it's been a little bit creepy how every question you seem to have a slide ready for it. How about I throw you a curveball? Can we see a demo of all this stuff?
Certainly, yes. Let me bring up my screen.
And for everyone who's at home waiting to see the demo, we're actually going to talk a little bit about how you can migrate to use this going forward, if depending on what Sudhir covers in the demo. So stick around if you're excited to actually get to use these new M6G instances.
Okay, is this coming through okay?
Yeah.
Great. So this is going to be a pretty quick demo and pretty straightforward. So what we're showing here is a web tier kind of setup where you have a client that's sending a bunch of requests through an Nginx server, proxying back to a bunch of child processes, which is a simple AAO HTTP program. We'll look at the code in just a little bit, but what it's really doing is serving these requests, sending back a hello world along with the architecture type. And we're also using supervisor-D as a process manager with the different processes that we have spun up to serve these requests. And we're running the exact same setup on an M6G and also an M5, and we'll compare the time it takes to complete and also the requests per second. Just going to start the demo. So we're going into the console, and we're going to spin up the M6G instance in the top window. As you can see, the unit-A, that's an AR64, that's an ARM64 machine. And then down at the bottom, we basically spun up an M5 instance. So let's look at the different pieces of code here. So we start with the hello bench, the process that's serving the requests. Simple Python code, and what it's basically doing is the hello world and calling out the architecture. And it's also setting up the traces for the Datadog monitor that we're going to use. So a monitoring agent that you can use just like you do on any other x86 instance, you can do it on an ARM64 instance as well. Supervisor deconfig, so basically that points to the hello bench process and it manages that. And let's look at the Nginx web proxy web server that we are running. As you can see, that's pointing back to the AIO HTTP hello bench 16 processes that we have kicked off. So a look at what all we have running together. So we have the Datadog traces. We have the Nginx worker process. And then we also have our hello bench processes that have been kicked off. So now the benchmark. So the benchmark here is we're going to send 500 requests concurrently and up to 5 million in total. And we're going to look at the M6G in the top window, the M5 on the bottom, and we're going to compare sort of the runtimes and how they stack up against each other. So this demo is accelerated, by the way, just so we can get to the final result. And you can see Datadog is capturing some of those traces for both M6G and M5. So M6G is nearly done here. We're going to accelerate and move forward to the finish and take a look at the final result. Just be completing M5 here in just a second. There you go. And what you see here in total time taken, the M6G has taken around 1,000 seconds, which is about 25% lower than what you see on an M5. And correspondingly, if you look at the requests per second that were served, you can see that that also correlates to about 25% more requests per second on an M6G versus an M5. Cool.
Awesome. Well, this sounds great to me. I have some questions folks in the chat have some questions. I know your time is valuable, Sudhir, so we'll try to make it quick. My first question is, how can I migrate? So I'm sold, right? I get all the benefits of the new Graviton chip and the M6G over the M5. But people are probably wondering, how can I migrate my workloads to M6G? It's a new architecture with ARM-based architecture, right? Like, what does this migration actually look like?
Yeah, I think that's a perfectly valid question that we get all the time from our customers, and it's usually top of their minds, especially when they're dealing with an architecture like ARM. And what I want to share here is some of the progress and the momentum that we've seen overall in the ARM software ecosystem, and some of the building blocks that we have that will allow you to take advantage and migrate some of your workloads. So what we've seen is that ever since we announced Graviton and now onwards to Graviton 2, the momentum within the ARM ecosystem has been significant. So firstly, starting off with the OSV and ISV support. What we have today is broad support for ARM64 as an architecture across all the key Linux distributions. So from Amazon Linux 2, Ubuntu, Red Hat, SUSE, and then more, right? Like Debian, we have Fedora, just pretty much all the popular Linux distributions support ARM64 as a first-class citizen. And we have the exact same armies available for our customers. If you go to the console, it's basically a radio button that just say, okay, do I want x86 or do I want ARM? Just pick it, and you can run the army and launch the instance. So, and you get all your key packages in much the same way as you would with any other instance. Secondly, in terms of containers, so we are finding that a lot of our customers use containers. Docker has added support for ARM, and pretty much most of the Docker official images that support x86, they also have support for ARM64 today. And Amazon's own ECS and EKS services support the ARM64 architecture, as well as we've now most recently, as of a couple of weeks ago, added support for ARM in the ECR, the Elastic Container Registries as well. And for micro VMs, we're also making sure that Firecracker now includes support for ARM in addition to x86. And for a lot of the tools and software that our developers rely on, so be it our marketplace, which is our curated collection of software catalog, be it all the popular agents like Systems Manager, Inspector, that our customers use on x86 instances, and also our entire AWS code suite for code deploy, code pipeline, code build, code commit. All of that today fully supports ARM as well. And Java applications tend to be architecture agnostic for the most part, so it's super popular, what we've seen in customers use adopting Graviton. And we have Amazon Corretto, which is Amazon's own distribution of OpenJDK, also releasing support for ARM as a first-class citizen. So across the board, a lot of momentum, and we believe there are a lot of really good building blocks for customers to use. And I also mentioned Datadog that we just showed in the demo. We have other big ISVs like CrowdStrike, security monitoring tool that also supports both the A1 and the M6G as part of Graviton instances.
Yeah, that's pretty comprehensive. And just to add to that, there are a lot of other workloads that also work within the ARM ecosystem. For example, you mentioned Docker containers. So one of the most popular runtimes for web applications these days, Node.js, there's a very well-supported Docker image for Node.js that runs on ARM. Likewise, if you're a .NET developer, there are .NET images that can run on ARM. So, the ecosystem is way ahead of where it was just a few years ago, and it's really interesting to see the amount of momentum around it.
Yeah, absolutely. Yep.
Now, there's a question in chat about when did we launch this? I saw that was answered, but I think to kind of bring that question home, that demo that you showed us, for those of the people watching Twitch, can they go and launch an M6G instance right now and run those exact same benchmarks that they saw?
Yeah, absolutely. So we launched M6G just earlier this week on Monday, which is 5/11, and it's generally available in 6 regions. So we have 3 regions in the US, so North Virginia, Oregon, and Ohio. We have 2 regions in Europe, which is Frankfurt and Ireland. And we also have 1 region in the APAC region, which is Tokyo. Yeah. So 6 regions today. You can go launch it, and we'll be adding more regions going forward.
Another question here from Werner G. Imagine. Is this the new Amazon Redshift RA S3 instance. So I guess the more general version of that question would be, what are the various AWS services that this thing powers? For example, you showed Memcached earlier on. We know that Memcached, we offer a managed version of Memcached via Elasticache that runs on a variety of different M-class instances. Is this, is this integrated with that and potentially other services across AWS?
Yeah, so there are a number of services that are actually actively testing these M6G instances and plan to support it. Specifically, Elasticache, we'll expect some more support here actually in the coming months, very soon. And one of the data points we have from the Elasticache team as they tested M6G was they saw up to a 50% improvement on Redis versus M5. So it's definitely looking very encouraging from that perspective. And we expect Elasticache, EMR, even our own Elastic Load Balancing services, all of those to support M6G very soon.
Can I just take a moment to digest all of this? Usually in the in the hardware world, we don't see this kind of massive improvement very often, right? If you look at the kind of delta improvements between different generations of processors or architectures or memory solutions, they're usually in like the single-digit range. Low, double digit between 10 to 20% improvement is considered very significant, right? You also see this in the GPU space, but to have this kind of performance for general compute just blows my mind.
Yeah, I think a lot of that goes into some of the optimizations that we've been able to do as part of our custom silicon initiatives. I completely agree with you. I think this is an order of magnitude improvement. Not just in performance, but also the lower price. And the combination of the two, we hope our customers find very compelling.
So really quickly, top to bottom, and correct me if I miss anything, launch of the new Graviton 2 custom silicon processors in collaboration with Annapurna Labs, available generally to everyone as of this past Monday in the M6G instance class. Again, this being the first 6th generation instance and being specifically tied to the general compute class. So again, applicable to a large number of workloads. A large number of benchmarks that we included in here that, again, this is recorded so folks can go in and check those out, as well as a large number of integrations with partners such as Datadog. We saw the testimonial from Honeycomb as well there for the price to performance improvements over the M5 class instances previous to this.
Yep, absolutely. Those are right on.
Awesome. Well, I wish we could sit here and geek out about the new M6Gs all day, but we do have 3 other launches to get to. So without further ado, I wanted to say thank you, Sudhir, again for joining us from the EC2 team, talking a little bit about Graviton 2 and the new M6Gs. Thank you again for coming out. Stick around. We will be right back with another guest. This time we're going to be looking at a demo on AWS Glue, new launch for streaming ETL. So stick around. We'll be right back. All right, we're back. I promised another demo, and we've got another 2 after this one as well. So we're going to fly through it. So again, here we are going to be talking about a very exciting launch, and it is streaming ETL via AWS Glue. Here to talk to us a little bit more about this is Mehul Shah, GM for AWS Glue and Lake Formation. Mehul, thank you again for joining us on the show today.
Thank you for having us. It's a pleasure here.
Okay, so again, not launching an instance class like we spoke about before, but this is a very exciting launch. Can we talk a little bit about what ETL is, because I think that's an important primer before we get into the streaming component and how it fits into Glue largely.
Absolutely. So ETL stands for extract, transform, and load, and it's actually a very large industry behind ETL tools that you can find in the market. It's an $8 billion industry, and it's actually growing pretty fast. ETL, in some sense, is the first mile for doing data analysis. So if you want to do any kind of analysis over your data, typically you need to prepare that data. You need to restructure that data, enrich that data, format that data so that a bunch of different engines can analyze that data. Sometimes you'll have SQL engines, data warehouses analyzing that data. You might do big data processing over that data. You might want to do some stream processing or monitoring and inline analytics, machine learning over that data. In all of these cases, you really need to canonicalize and prepare that data so the analysis can go really well. And so ETL is sort of the short form of data preparation and data cleaning. It's really born from the term extract, transform, and load, when people used to just do all of their data and data management on databases, and they would spend time extracting it, transforming it, and loading it into data warehouses.
Yeah, and we won't dive too deep on the history of inefficient practices of ETL.
Yeah.
But broadly, I think, you hit the nail on the head again, like taking data from where it's collected and transforming it for some sort of consumer down the road is very fundamental to being able to actually achieve business value from whatever you're trying to do with that data, right? And so you mentioned before, this is a very large part of the backbone of a lot of downstream applications that are trying to consume this. So I've messed around with Glue a few times, and I'm a big fan of it. But could we review again, for those that may not be as familiar, what AWS Glue does as a service?
Sure. So Glue is a managed ETL service. It actually has three main components for you. At the core of Glue is a serverless ETL engine based on Apache Spark. Apache Spark is a big data processing framework for doing all the transformations that you want to do. It works over structured data as well as unstructured data, which is nice because that's a lot of the data that's coming in today through, say IoT applications, IoT logs, application logs, news feeds, social feeds, ad tech logs, and so on. A lot of this stuff is unstructured to varying degrees. And Spark is actually, the perfect sort of engine for running transformations over that kind of data. So at the core of Glue is a serverless Spark ETL engine that you can use. Glue also offers in its console a number of ways of monitoring and actually generating jobs for doing transformations. So you actually don't have to know a lot about Spark to get started with Glue. It'll generate those scripts automatically for you. And then, off you go. Prior to Glue Streaming, the ETL components around Glue were entirely focused around batch processing. And now with Glue Streaming, what we can do is allow you to do a lot of that transformations in line as the data is streaming through from various streaming sources, and make all of that available to you inside of your databases, data lakes, and data warehouses. Other portions of Glue are around organizing your data or the metadata in a data catalog, and a workflow system for scheduling your jobs. But the piece that I think we're going to talk about today is that ETL engine.
Yeah, one of the things that you said earlier that caught my attention was how people used to do this. The genesis of this kind of ETL style workflow comes from an era where everybody did everything in a single database. Right, and the landscape has changed so much now. It's so much more common to see these kinds of polyglot backends where you have data spread across various silos, which kind of puts more of a focus on how efficient you can make this kind of ETL workflow, right? So you mentioned serverless a few times. Can you talk about how does that work exactly? How do we wrap our heads around that? How do you apply this kind of serverless workflow to a streaming model?
I think that's a great question. So let's first talk about what serverless means. Serverless in our context means that you give us a Spark script. Typically, these scripts are written in Python, Scala, or Java. Those are the three languages that are supported. Glue will generate those scripts for you if you need, but if you want to customize those scripts as you want, you can certainly write your own. And you submit those scripts, and behind the scenes, what we do is we spin up the necessary resources to run those scripts at scale. You don't have to spin up any machines, configure any machines, configure any software, do any kind of upgrades, none of that. So serverless is just entirely exactly what it says, is you give us the job, we do the rest for you. Now we have that technology, and we built that technology for jobs that you run off on a schedule, for example, a daily or hourly or every 15 minutes. But in some cases, you really want to be processing your data continuously. And so using that same technology, we now allow you to run Spark scripts that are streaming. And what that means is it's running all the time. And the underlying resources are being optimized for you continuously. And so that's how we actually apply that technology to streaming jobs. You give us a job that's defined as a job taking data from streaming sources like Kinesis or Kafka that are continuously giving your data. And then what we do is we run the transformations that are in that described in that Spark script. And then the output goes into one of many destinations, S3, data warehouses like Redshift, or other databases like JDBC databases.
So it's really exciting to me how far sort of data pre-processing and ETL technology has come in a very short time. We talk about Spark here and Glue being a fully managed serverless, offering of Spark. Folks previously had to run and manage their own Spark clusters, and batch was sort of the default there, right? And now as we sort of go on, we have a serverless streaming offering here in this launch with Glue. This is immensely exciting. And to sort of touch on, how easy it is to write some of this ETL code. Previously there was a lot of skill that went into not just managing those clusters, but interfacing with Spark. Using Python, you can use PySpark libraries and just thinly wrap some of these very common Python data munging tools like Pandas, for example, or Apache Arrow, and get the transformations you need, and those work directly in Spark. So I'm interested to see now with the streaming offering, what are the control levers here? I know previously you could define maximum batch sizes and maybe like your max throughput, for example, but what does that look like for streaming now?
I think that's a great question. So today, what we're really focused on is giving you the ability to process the incoming data at the rate that it's coming in. So the biggest lever that you have with Spark Streaming is the amount of resources that are actually dedicated to your streaming job. It's not just a single machine that you can actually dedicate, which is the nice thing about Spark, which is a distributed platform. So you give us, a sort of a maximum DPU. DPU is how we allocate, how we measure the number of resources that are used behind the scenes. And then what we'll do is we'll automatically spin up just enough resources so that we can incorporate all of the stream that's coming in and do all the computation over the stream, and then bring that data, as I said, into one of the various destinations. So that's one of your biggest levers. Another lever that you have in Spark Streaming, and this is actually pertinent for later downstream analysis, is how you're going to organize that data. Does that data get organized in a way where it's useful for doing SQL analytics, or is it organized in a way where it's useful for doing some other type of analytics? And it depends on, depending on the kind of an analytics you want to do, you want to organize your data differently. And so what Spark Streaming allows you to do is repartition your data as it's coming in based on the attributes that are in the data. And this is actually a non-trivial transformation. You've got to buffer a lot of data as it's coming through and make sure that it's allocated just right and it shows up in the right place. Another lever that you have is, of course, how often you actually load the data into one of many destinations. You can do that based on some kind of timeout. So instead of saying, hey, this is the size of your buffer, every second, every minute, and that's going to control sort of the latency that you have for that data appearing downstream for your analytics. So latency, layout, compute size are your three main levers. And of course, all the other levers that you get as you're writing your Spark streaming scripts in terms of all the various transformations and operations that you can do for combining data, for enriching data, for doing machine learning, graph analytics on the fly. All that is available to you at your fingertips.
You mentioned the real-time stream processing aspect of this kind of workload. And with these control levers, let's say I go in and define a set of resources that are not quite sufficient to keep up with the rate of data coming in from my real-time data source. What happens if there's a bottleneck in the pipeline there?
Oh, I think that's a great question. One, you can monitor if there's a bottleneck in the pipeline or not, because you can see the data actually backing up in some of the sources. So Kafka and Kinesis, you can actually take a look at the number of records that are kind of building up. And for Spark streaming jobs, what you can do is you can actually just allocate more resources, and it'll automatically kind of scale to the number of the amount of resources you need to bring the workload in balance with how fast you can process that workload. So it's actually pretty simple for you to do that. Today, you still have to monitor it yourself. You can either put an actuation loop around it, or you can do it manually. Soon enough, what we're going to do is we're going to be working on, or we are working on auto-scaling technology that will automatically scale based on the amount of load that's coming in. So right now, you kind of pick a pretty good number, and based on the number of shards that you have, for example, in Kinesis or Kafka, it actually works pretty well. But for more bursty workloads, you'll see auto scaling coming soon.
So is it fair to kind of draw an analogy to, let's say, DynamoDB, instead of kind of saying the amount of provision read and write units I'm going to want up front, I can choose an on-demand version of that instead?
Exactly. That's exactly right.
Well, when we cover a lot of launches on this show, and while for some, if it's a very foundational technology in the stack, even incremental percentages are important. Something that's really cool here to me is how much of a game changer this launch is for the actual architectures for managing ETL on streaming implementations, right? This is not something that's very trivial to launch, and I think that maybe walking through some of the ways customers tried to implement this previously will be a really strong testament to that. Again, these are still performant architectures, but when we think about having a truly purpose-built sort of tool, having streaming for Glue here really does change the game. So, could you walk through some of the architectures that we've seen customers use to try and implement, streaming ETL previously?
Sure. So, as you can imagine, because everything is based on Spark, we've seen customers actually, roll their own streaming architectures. Using a variety of services. So you could just, for example, run Spark on EC2, or you could actually use EMR, which is our managed Hadoop offering, and you could run Spark on those offerings. Now, of course, you get similar benefits of being able to run Spark scripts that make it easy for you to incorporate and sort of run analysis in real time. But the benefits around serverless aren't there. You still have to manage all of those virtual machines. You have to know how to configure those virtual machines. You have to monitor if those machines are going down so new machines can come back up. You're basically doing both system administration as well as running your streaming jobs. And now at least that entire component is completely gone. Another alternative is for people to use existing streaming platforms like Kinesis to get their data into a data lake or a data warehouse. Kinesis Firehose is actually a great example. It's a very popular product. The challenge with products like Kinesis Firehose is that it's really intended for getting the data into the destination, and you can't really do very complex on-the-fly analytics as the data is coming by. And sometimes you really need to do that. For example, if you want to enrich your data as the data is coming by with data coming from, say, a customer profile database, so that people know what to do with the customer records or transactions that are coming through. Or imagine you want to join two streams together, one coming from sort of an ingress and another one coming from, say, an egress, to find out the common packets that are coming through. You won't be able to do those kinds of things on the fly with something like with Kinesis Firehose. You have to do it post hoc. Here, you'll be able to do it inline. Another example is fraud detection or machine learning that you can, again, implement in Spark Streaming that you have to do post hoc when you're using a traditional streaming service just to get the data into a data warehouse or data lake. So the idea that you can do complex on-the-fly analytics is very powerful. So both the ability to avoid all of the system administration and management, and also insert complex analytics on the fly, I think are the two main value propositions here that we've enabled with Glue Streaming.
Yeah, it really feels like, again, best of both worlds. You just covered it. It's, you get all the customizability of working directly with Spark, but then you don't have to use some of these workarounds that can increase latency for actually performing complex real-time analytics that, the Firehose to S3 to Lambda to another S3 to another Lambda may actually pose. So very exciting. And again, anytime we can sort of streamline the number of services folks need to use, or the amount of system administration or undifferentiated heavy lifting, that's always a win in my book. So, I'm sold. I know this sounds very easy to use, but is there any chance we'd be able to actually see this in action?
Absolutely. We have our product manager, Andy Betty, who's ready with a demo to show you an example of how actually you can use it for a very relevant use case today.
Okay, awesome. So we're going to actually take a quick, like, 5-second break. I don't know what you'll be able to do in 5 seconds, but hang in there. We will be right back. A little longer than 5 seconds, but we're back just like I promised. So again, here joining us to show us a demo of Glue Streaming ETL is Andy from the AWS Glue team. Andy, thank you for joining us.
Thanks for having me.
Cool. So why don't you walk us through exactly what we're going to see here with Glue Streaming ETL?
Absolutely. So today I'm going to demonstrate how streaming ETL functionality in AWS Glue allows you to ingest streaming data like IoT logs and move them into a data lake so that the records are available for analysis in near real time, like Mehul was discussing a little bit earlier. In this example, we're going to be simulating logs from medical ventilators like those being used in hospitals during the current pandemic. This is the log format we're using. It contains metrics like oxygen level, pressure, device serial number, and manufacturer. We're sending these logs over an Amazon Kinesis data stream, processing them using AWS Glue, and then writing them to an Amazon S3-based data lake. So the first thing that I'm going to show you is that the data stream is being populated. So I'm going to go here to the Amazon Kinesis data streams console. And in these charts, you can see that there's data coming over the stream. The next thing I'm going to show you is the AWS Glue console. This is the Glue jobs console. And you can see here that we've got a Spark streaming job currently running. It's been running for over 19 hours now. And because streaming ETL jobs can run indefinitely, I haven't set a timeout on this one, and it'll continue running until I shut it down. On this screen, you can see the script that Mehul was talking about earlier. So AWS Glue generates the script for you, so you don't have to write Spark code yourself to get started with streaming ETL. But if you're familiar with Spark structured streaming code, it's easy to customize the starting point that Glue gives you for your own needs. This particular job is, like I said, reading data from the Amazon Kinesis stream. It's converting the data format, then writing it to S3. It's also updating the Glue data catalog so that it's available for analytics services like Amazon Athena and Amazon QuickSight, which I'm going to show you next. So first, we're going to start with Amazon Athena to see what data that we've processed. So on this screen on the left, you can actually see the data table that the streaming ETL job is populating. Note here that these items marked partitioned. One of the cool features of streaming ETL in AWS Glue is that you can organize the data not just by year, month, and day, but by the contents of the data itself. And so in this case, the manufacturer field in each record. And you just saw this query complete over here. And as you can see, this data arrived just moments ago, seconds ago. It's 1:03 on my clock, and it's 1:02 for this most recent record. So you're able to analyze the data in very close to real time. I'm also going to show you dashboards that are built on the same data so that you can do more online analysis. So this is a simple dashboard that's built in Amazon QuickSight. And in this first chart, you can see the rate at which data is coming over the stream and being written to S3 so that it's ready for analysis. Now, imagine in this case that we want to check on whether there's a problem with the hypothetical ventilators that we're simulating. We can use these second two charts to see if there are anomalies in the data, as well as to identify where the problem lies. So as you can see, these oxygen levels do have anomalies. And in the second chart, we can look here and see that the problem seems to be with devices manufactured by Acme Corporation. And in the real world, we might go and investigate those devices to see what the problem is. So these are just a couple of examples of what you can do with this new functionality. So in the demo, I showed you how streaming ETL in AWS Glue allows you to move streaming data into your data lake in just seconds. and makes it available for both batch and online analysis using AWS Analytics services. And so for more information, we've got an AWS blog post on this topic, as well as documentation that's available today.
AWS Glue, a purpose-built ETL solution that service from AWS that enables entirely serverless ETL, now affording streaming capabilities for streaming ETL. So rather than having to string together a bunch of services in what would otherwise still be an event-driven architecture, you can now take a data stream like Kinesis, Kafka, Apache MS, or Amazon MSK, managed service for Kafka, and now directly tie Glue streaming ETL jobs as either ongoing or time-gated as a consumer of the data from the stream to deliver real-time data processing. Awesome. Very, very exciting stuff. Let's see right now if we have any further questions from chat. I'm not seeing anything else on my end, but again, Andy and previously Mehul, whose name is on the screen right now, thank you again for joining us to show us a little bit about this very exciting launch for streaming ETL for AWS Glue.
You're welcome. Thanks for having me.
Yeah, anytime. All right, well, next up, we have a very exciting launch. I know I say this every single time, but again, there are just so many very exciting launches to get through here on the show. Next up, we are going to have a deep dive on Amazon Augmented AI, also abbreviated A2I. So if any of you are interested in that, stick around. We will be right back. All right, we're at the midway point here on the show. We have 2 demos down, and we've got 2 more to go. But before we get into the next one, we've got an exciting opportunity for everyone here who's tuning in.
Yeah, that's right. We have $10 of promotional AWS credits. If you can help us fill out a survey, let us know how we're doing, what topics you'd like to see, what topics you want to see less of perhaps, but just give us feedback, because a lot of the stuff that we do is centered around what you want to see, and it really helps us improve the show. So please do us a favor, go fill out the survey, and we'll have a link in the chat where you can go and visit to get that credit code and fill out the survey for us. And it just takes a few seconds. It's very brief, I promise.
Okay, enough of the survey pitching. Again, check that out if you'd like to help improve the show or get some AWS credits. But more importantly, we've got another exciting demo lined up for all of you. So without further ado, with the magic of production, we have Anuj Gupta, Senior Technical Product Manager from Amazon Augmented AI, joining us today to talk a little bit about this very exciting service that has recently gone generally available. Anuj, thanks for joining us. Why don't you tell us a little bit about Amazon Augmented AI?
Yep, definitely. Thanks for having me over here. So Amazon Augmented AI is a new service we launched in the preview at reInvent 2019. So a few months back, and based on the customer feedback, we went general availability in 12 regions on 24th April, like just 2-3 weeks back. Inherently, like before we get into A2I or Augmented AI, let's talk a bit about machine learning in general. So machine learning models, a lot of them inherently give you probabilistic answers. So a machine learning model is going to tell you it's like 80% confident or it's 90% confident that a dog is present in this photo or not. Many of the times there are not like black and white answers. And these kind of scenarios, whenever the machine learning model is not confident, or as we call it, like it's a low confidence result, you want a human to come in and have a look at that piece of data and say whether it's a dog or a cat or something else. So people want to conditionally route their machine learning inferences for a human to have a look at and make sure like they're getting consistently highly accurate results from their workflows.
So, you know, I've worked to design a lot of machine learning systems in the past, and sort of what you're describing is folks want the automatability and the speed and the cost savings that come along with automated machine learning oriented inferences, but they also have situations where they want to have this sort of higher quality, higher cost human review. And it's hard to build previous systems have done either entirely one or the other, but there have been a lot of customers that are trying to sort of build a hybrid system before. And this is no small feat.
Yep, definitely. I mean, customers either have to go to like ML only route or they have to go to like 100% human only route. But at the end of the day, customers have been telling us they want like the scale and the speed of the machine learning, and they really want to use the human intelligence where it's truly, truly needed. And then there's a large demand for it. Like people also want to use human oversight to really make sure they can trust their machine learning models, whether it's internally or externally. And we were fortunate enough to work with T-Mobile as a customer even before our launch, where they were trying to build this machine learning trust within their organization by randomly selecting, let's say, 10 or 20% of the data and then passing it for a human review. And this way, you can really make sure that your machine learning model is giving you the output you expect, and people can calculate like machine learning metrics like accuracy, precision, and things like that.
So if I recall back to the big picture machine learning workflow, you start with a data set, you go through labeling, you go through training, and then you optimize this thing, you deploy it into a fleet, you do some inference. This is a very large set of tasks to do. Can you kind of situate us within that space? Where exactly does A2I fit in?
Yep, definitely. So as you kind of pointed out, Rob, like there are multiple steps in a machine learning pipeline or the workflow that customers take. The first step is training your data set. And once you have a very good data set, you can train your machine learning models. And AWS provides a lot of different services like SageMaker Ground Truth to help you really train the model. Then you can deploy your machine learning models into production. And you start like serving the inferences or start serving the production data through your machine learning model. And that's where really A2I comes in. A2I can pick up the low confidence predictions from your machine learning models, whether it's hosted on SageMaker, whether it's any of the AWS AI service like Recognition, Textract, or even if you are having like machine learning models hosted on any of the other cloud providers or any other places. You can bring in those low confidence predictions, and you as a customer have complete flexibility in defining what is low confidence to you. And you can bring in that low confidence prediction and ask a human to review it in the inference stage, which is generally the step 3 or step 4 of the machine learning workflow overall.
So what we really start to see here is this spectrum where if we don't have to go full human or full AI model automation, we have the ability to conditionally route our requests as we desire. And you hit on the topic of, confident or good enough responses are subjective, right? I would very much think we would all be in agreement that the confidence value we would want for detecting a medical condition would be substantially higher than, some sort of much lower level task that has a smaller blast radius, right? And so again, you mentioned customers can entirely set the threshold for routing these requests. When I think about this largely sounds like a very undifferentiated problem, right? Like anybody implementing an AI or ML system is going to face this at some point, regardless of whether I'm trying to classify cats or dogs or corn from apples, right? So the ability to offer this as a service in augmented AI sounds really appealing to me. I'd much rather use a managed service here than to have to build this from scratch. So I'm curious, and I'm going to pose the question to you now. You said there's a lot of flexibility. I can alter the confidence threshold. What does it actually look like to use augmented AI?
Yeah, definitely. So there are kind of 2 steps as we define in using augmented AI. The first step we call is the initial configuration. And in this first step, you as a customer have complete flexibility in defining like, what does your data look like? What is the low confidence result for you? Or if you want to do random sampling, you can define those conditions. You can define what is the choice of human review workforce you want to use. So with A2I, you have options to use Amazon Mechanical Turk as a workforce. You can use any of the vendors listed on AWS Marketplace, or you can even bring your own employees or your own private workforce on the A2I platform. So, and then the next thing you also have to do kind of as a part of initial configuration is like, what is going to be that UI or what is that user interface that people are going to see when they review these machine learning predictions? Once you do this initial setup, and all of this can be done through very easily on console, and I can quickly show you that as well. Once you do this initial setup, the next step is to start using A2I. So you can directly call A2I APIs in case you're using any A2I in your custom machine learning models, or in case you're using A2I with, let's say, pre-integrated services like Recognition and Textract. And these are like Amazon Recognition and Amazon Textract are AWS AI services. You can just pass in a single parameter in your Textract or Recognition calls, and it will conditionally route to A2I. So to kind of recap, like the first step is do your configuration, really set it up what you want. And then the second step is just start using it.
So this starts to bring in the conversation around observability and behavior for a machine learning system. We mentioned before that there's things on the training side. Again, A2I focused on observability and control over the inference side. You mentioned a lot of different options for bringing my own model. I heard you say SageMaker, text-extract recognition, which are managed AI services from AWS. But in all honesty, it sounds like I should be able to plug any sort of model, machine learning model, into A2I. Are there any other options? Like, what is the breadth of options available there?
Yeah, the breadth of options is completely like up to the customer. Like we do not, let's say, like restrict in any way, as to say. So customer like A2I APIs are public. Customers can directly use A2I APIs. So in case customer is hosting their model on SageMaker, or in case customer is hosting their custom comprehend model, or in case customer is using Amazon Textract or Amazon Recognition, or in case customer has like some of their machine learning models on other cloud providers or on data and things like that as well, they can still use A2I, because inherently customers have been telling us they need human in the loop, irrespective of the fact where their machine learning models are. And we want to make sure customers can like really use this human in the loop capability.
That's super exciting. I know that was like a subtle footnote thrown in there at the end, but essentially anyone can front an ML API, regardless of whether it's a rolled custom model on another cloud provider and even a managed service on another cloud provider, and actually access easy off-the-shelf human-in-the-loop functionality by sending those requests through Amazon A2I.
Yeah, before we go on, I want to call out an interesting question in chat by Runer_G_Imagine. I don't think he was being serious, but he asked, is Bill Vert a human or a bot? Now, I know, Anuj, you work with Bill, he's your teammate. And I think it's a silly question, but it kind of brings up the point, let's take this kind of chat support and automated question and answer kind of use case. We've seen this as one of the most common use cases for AI and ML. How applicable is A2I in this case? Is it applicable at all?
Yeah, definitely. As I mentioned, like whenever, let's say you are doing any kind of machine learning application, you can like let ML take the majority of the workload through its predictions. So even in this scenario as well, like ML can be responding to, let's say, your customers wherever you think you can provide a good service through ML alone. And again, you as a customer has preference of choosing what is that good enough service for your use case. And you can ask, let's say, a human to come in and provide some answers or provide additional data or flag it for someone to review in an offline manner, and really use that human intelligence wherever you need it. And just to kind of, I think, Rob, you bring up a very interesting use case, but like there are a lot of other use cases we see in this kind of a domain, like whether it's document processing or image analytics or video processing or advertising or medical field. Like we see a lot of different applications where people want to use the symbiosis of humans and ML together.
So we talked through the chatbot scenario right here. Again, sort of low confidence sort of inferences to a human. Are there any customers that have been using A2I that we can sort of share their experience with as a testament to the value that they receive by using this?
Yep. In addition to the T-Mobile example that I shared like a few moments back, like we were fortunate enough to work with National Health Services in UK. So National Health Services Business Service Authority is a public organization. It's a government organization in UK, and they process medical prescriptions for UK citizens. They process approximately 54 million prescriptions per month, and that's a lot of volume. And these prescriptions could be either printed, handwritten, and they come in a lot of variety. Like when you're dealing with such a large kind of data, the standardization gets kind of really tricky. And they want to extract with a very high confidence the details like what is the prescription, what is the name of the person, what is the drug. And these kind of use cases are very critical. Like you won't want anything going wrong in this kind of a use case. And they are using machine learning. They look forward to using machine learning. And in this case, Amazon Textract for a lot of their workloads, and really include or call upon the human intelligence where it's truly needed. And they can have the accuracy of the human intelligence with the speed and automation of ML. Interestingly, this is a customer also referenced on our Augmented AI website. I will highly encourage to read more about that in case you guys are interested.
Wonderful. So again, any sort of AI ML model, whether it's sort of a chatbot or a text prediction model, whether it is OCR in the form of text extract for prescription processing. We mentioned recognition as another sort of common use case here for maybe image recognition or object classification. Do we have any customers using that we can talk about?
Yep, definitely. So let me talk about this customer, Widmob. Widmob is a creative ad agency, and again, we were fortunate enough to work with them. They used recognition video to extract a lot of data from their advertising videos. So they process and create like a lot of intelligence around these ads that are created, and they really want to make sure that they are able to not only provide why did a ad perform, like, or how did an ad perform, but why did it perform the way it did. And this customer, using Amazon Recognition, their custom model, and Amazon A2I, they were able to make their workflows over 90% efficient. And another thing was, like, because they could rely on a human backstop, this means that they can push their machine learning models into production really quickly. They don't have to wait for their machine learning models to be really perfect over a long period of time. You know that there's a human backstop that's going to catch any of the low confidence stuff. And they were able to decrease their time to market by 3x. And again, this is a reference customer available on our website as well. Really, really happy and glad to be working with customers like these.
The time to market thing is very interesting. That had not really occurred to me as one of the main benefits of using a hybrid model like this. But now that you mention it, it's kind of, it's very powerful.
Yep. I mean, definitely, because like customers keep on telling us like they want to use the machine learning, but they also want to start using it quickly. And all of us know like deploying a machine learning model requires a bunch of talent. AWS provides a bunch of services to help customers in this area, but A2I can really help customers really push their models into production quickly, knowing that there's a human backstop.
Yeah, definitely.
Anuj,
well, I really want to see a demo now. We've talked so much about this service. There's so much going on here, and I think I can't be the only person who's really on the edge of my seat waiting for a demo.
Awesome, definitely. Let me share my screen over here. Okay, so I'm just going to go into my AWS account over here, and I'm going to search for Amazon Augmented AI. So this is the A2I console. You can come over here and do a lot of initial configuration that I was talking about. So you can say like, okay, where do you want the results to be stored? What is your task type? You can select extract recognition, or you can select any of the custom ones. And for example, if you select extract, you can define the conditions based on the task. And these conditions are very dependent on the task type you're choosing. So for example, for document processing use case, you might want to say, in case I'm not able to find first name Anuj Gupta on the document, I want a human to come in and have a look, or something like that. So you can do all of this setup in console. But another good thing that I just wanted to show you guys is we have actually created a lot of end-to-end notebooks, and these are directly hosted on GitHub. So you can just download this notebook and get started over here. So that's what I'm going to go through now, because that is going to really show you how easy these notebooks are to use for demo purposes. So I have created a notebook instance under Amazon SageMaker. Let's just open that up. Let's open the Jupyter. And the notebook that I'm showing you, you can go and download it from our GitHub like right today itself as well. Let's wait for this notebook to open up, and I'm gonna just restart and clear everything so that we have a clean state to start with. Now, you will notice I'm only going to click run in this notebook. I'm not going to do anything else because, as I mentioned, a lot of things have already been set up for you. What you will need to do is just to make sure that you have some of the prerequisites set up. You will need to set up your work team, which is a set of group of people that you want to work on the tasks. And then you need to tell us what is your S3 bucket where you want the human reviewed results to store. And that's all you need. And those are the two things I have already input over here. So now let me just click on run a few times. And as I'm clicking through the run, you also have a lot of instructions in this notebook so that you can help understand what is the notebook actually doing. So in this scenario, I'm going to run this document through Amazon Textract, and I'm trying to identify full name, phone number, and a bunch of other fields from this document. So this is a sample document I'm using for the demo purposes. So I'm doing that initial configuration step that I was talking about previously through our APIs. And given that it's essentially a notebook and all I have to do is press, my initial configuration was initializing, and within like 2-3 seconds, now it's active. So the next step, I'm going to send the document through Amazon Textract. And let's see what the result comes out of Amazon Textract. The way I had set up the conditions in this demo was that in a way that now a human loop has been created. And what it means is that a piece of document or this page of document is now sent for human review. So, and now you can see the status as well. The human loop status is in progress. So the next thing is I'm going to switch around the persona, and let's say now I'm the worker who needs to work on this document. So I'm going to go into this login website, and this is a website that customers get for their own accounts at the end of the day. And this is behind a login screen. So let me just log out and make sure you see the login screen as well. And customer can fully manage who logs into this website. We are not sending out this work over anyone emails or something. This is a very secure way to make sure work is done as per customer requirements. And then what I'm going to do is I see that there is a document analysis sample task in my queue. I'm going to say start working. And this is one of the pre-built templates that we provide. So you as a customer do not have to go and create this UI. We provide over 60 different templates that are again available on GitHub. On the left-hand side, there are instructions that tell me how to complete this task. In the middle, there's the document. And on the right-hand side is the data I wanted to extract out of this document. Now, you will see a lot of efficiency mechanisms that we have already pre-built from a worker perspective. So for example, if I click on this phone number, you see that the phone number has already been pre-populated by what Amazon Textract output was, so that I, as a worker, do not have to type in. And at the same time, you see this orange box around this field as well, so that it's easy for me to find it on the document. And then we can see like this full name as well, or we can see this home address as well. I also wanted to extract mail address out of this document, but as we can see, it's blurred and it's crossed out. It was not really identified by machine learning model over here. So I, as a worker, can come in and type in like 234 Main Street, any town, USA. Everything else looks good to me, so I'm just going to submit this task. Now, once the task is submitted, we automatically send a CloudWatch event to the customer's account so that customers know like that this piece of work has been done. And at the same time, we also store the result in the customer's S3 bucket. And you can come to the console and see this initial configuration that I had done on the console as well over here. So let's just look at the thing at the bottom over here that says human loops. You can see this has been created like just a few moments back, and the work has been completed because I just went to the UI and did the work. So let's open this up and see what does the output look like. So as I mentioned, we store the output in the customer's S3 bucket. It's a JSON output. So let's open up this output. Now, this is kind of difficult to read like this. So let me just open it in a JSON parser and an online JSON parser. Now in the output, you will see there's a section called as human answers, and that contains whatever answers I provided as a human. So over here, you can see mail address is a key that I specifically input in the document. And if I scroll down, I can see over here that 234 any street should be showing up as a value over here. So you can see this thing, 234 Main Street, any town, USA. Now this is available to you as an output as a customer, and it's up to you like how you want to use this data. You can parse it, or you can use it in any form and fashion you want. In case you are using A2I with custom machine learning models, you can also use this A2I output to retrain your models over a certain frequency. So for example, if you say like 3 months later, now I have a lot of A2I output and I want to retrain my custom model, you can absolutely take this data and retrain your model as well.
This is some super exciting stuff. I mean, again, after every organization goes 0 to 1 with machine learning, where they can ingest new data and serve inferences with it, they've trained their model. Let's say that they've gotten past that hump. Once it's in production, this is the exact problem that every single one of them faces. That or I shouldn't say most, but like not many teams sort of anticipate, because it's a higher order sort of problem once you've implemented your machine learning system. But truly, Amazon A2I is this fully fledged managed application proxy for taking that raw output from your machine learning model and being able to either directly serve that to customers or to have that human in the loop reviewing with an entirely pre-baked front end to serve this to your reviewing task force, right?
Yep, absolutely, definitely. And I think you summarized it really well over here. And also I just wanted to show on the screen share, all the resources that I shared with you guys today are present in these resources tab over here. So you right after this conversation or whenever you want, you can directly go and run any of these Jupyter notebooks. We also have some other material over here that it can help you get started on A2I. And at the same time, you can also see some of the other customers like NHS, Deloitte, T-Mobile, and how these customers are using A2I in their different workflows.
Yeah, and the thing that really impressed me was how portable everything was and how well thought out everything was. So when you showed us the JSON schema of the data from the human augmented data, that really convinces me that I might have a bespoke system, I might have a custom workflow, I might not be all in on the various solutions across AWS for running my ML powered workload, but this can still help me. I can still adopt this incrementally, and then you mentioned that we can take this data and feed it back into the system to train an improved version of the model. That's also very interesting. And you also touched on something that's very important, which is access control, right? As you were clicking through the Jupyter notebook, you were saying, look, the user actually has to log on here. There's a point at which you have fine-grained control over who can access this information, because chances are it's going to be very sensitive to the domain that your business operates under.
Exactly. And customers can maintain this team. They can remove anyone. They can do their Cognito user pool integration. So customers have a lot of control on who is accessing their data. There are also things like task timeout and things like that, where customers can automatically take something out of the queue in case it's very time sensitive or things like that.
Yeah, and sort of to recap something we didn't actually say before when we talked about the two worlds of either full automation or no automation in terms of serving requests like this. I think that something that's important to call out is that there are a large number of customers out there who, due to the lack of ability to implement observability, sort of default to not having that automation, right? So the launch of A2I is not just about improving the efficiency of folks that are already, trying to implement or have implemented a machine learning, workflow, but is actually going to open up the door to a lot of organizations that have wanted and are bought into implementing AI and ML, but haven't had the bandwidth to implement this sort of observability mechanism previously. So sort of a supplementary good to core functionality in machine learning, but I think it's really going to open the doors for a lot of a lot of teams that are looking to get started with this.
Absolutely, yeah. So I think it's not only you can add a layer of human oversight to the ML, but also to the customers who are really wanting to start their machine learning journey with a very critical workflow, and they want to make sure that they're not only using ML, but they have this oversight as well. Those customers can definitely benefit from A2I as well.
Last thing that you touched on, but sort of didn't spin it in this way. Even if so assume a certain percentage of requests go to a human, right, for review as we dictated by a threshold here. Let's not undersell sort of the value of being able to have the pre-baked sort of inference already filled in on that template, right? So even if it's a low confidence value, it's significantly lower lift for the human reviewer to simply change one letter than it is to completely review from scratch a blank template. We saw the outline as well. So, you still get additional value from your ML powered inference, and that's all baked in sort of by default in those workloads. So it makes even your human reviews more efficient than they would be previously.
Absolutely. And kind of the example that I showed, that had only kind of 4 fields in a document. Imagine kind of a mortgage application kind of a document, or some kind of a other document that has around 40 or 50 fields in the single page. In that kind of a document, or in that kind of a use case, you don't want each and every field to be input manually. You want to pre-fill it, show it to the worker, save them a lot of time. and make sure they are only present as a validator of this data rather than entering everything manually over there. I think that's a really good point, Nick, you brought up as well.
Awesome. Well, I'm not seeing too many questions in chat, but sort of to, again, go around the globe again for A2I, fully managed human-in-the-loop interface for machine learning inference. Bring your own model, the ability to either use your own custom model from AWS on SageMaker, AI managed services, or even any, a model you may have hosted on another cloud provider if you so desire. And the ability to then implement this observability, custom setting of thresholds, and to improve the efficiency of those human-in-the-loop inferences. Really bang on job, especially with the fact that we have such a large trough of Jupyter notebooks so that customers can actually walk through the exact same flow that you showed us today and plug in their own models to get started with that very, very quickly. Again, great. This is the Amazon A2I augmented AI launch. This is GA. We have the customer references. We have the Jupyter notebooks on there, as well as that talk from reInvent that I see there on the product page if folks are interested in seeing a little bit more about augmented AI in action.
Yeah, and special thanks to Bill Vert1 in chat. Total human being, 100%. Anuj, Nick, and I all agree that that is a human being. The next week we'll have Bill Vert2 in chat to help us moderate.
Or concurrently, we'll A/B test them.
Yeah.
Awesome. Well, Anuj, thank you again for joining us. Again, Amazon Augmented AI. Everyone, stick around. We've got one more demo that is Amazon Kendra Enterprise Enterprise Search powered by machine learning. Stick around. We will be right back. All right, we are back. Last launch of the day. Well, it launched previous to this, but is still very exciting and very hot off the presses nonetheless. Without further ado, we are here to talk about Amazon Kendra. Joining us from the Kendra and the AWS AI team is JP Dodell. Thank you for joining us, JP.
Thanks for having us.
Okay, so Amazon Kendra, I hinted at it before. It's enterprise-grade search powered by machine learning, but I know that we're going to talk about it in much greater detail than that. Let's just kick things off. What is Amazon Kendra?
Sure. So Kendra is a fully managed service. And in a nutshell, it's a highly accurate and easy-to-use enterprise search service that was built from the ground up using machine learning. So basically, you give Kendra all your PDFs, your web pages, your FAQs, wikis, reports, manuals, and any document, any text document you wish you could search more effectively. And Kendra allows you to ask questions using everyday language instead of clunky combinations of keywords. So you can still use keywords, of course, but now you can also ask your questions in much more natural and precise ways when you choose to. And using a combination of state-of-the-art deep learning models, Kendra will find precise answers, words, phrases, or passages that are buried in millions of documents. And it can do this with pinpoint accuracy. So instead of getting these long lists of documents when you search and with questionable relevance, you get accurate answers from Kendra. This is one of Kendra's key value propositions, and I'll show you some examples shortly. And of course, all of your data is encrypted, in transit, at rest, with AWS KMS keys, or even you can bring your own customer managed KMS keys. And best part about it is that it doesn't require any machine learning expertise.
Well, I think we've all had that experience of trying to find something on some sort of document search portal and just coming up with some really noisy results. You mentioned a couple of the ways that Kendra was designed to address the pain points of this kind of customer search use case or the enterprise search use case. Are there any other pain points that we use to kind of inform how we built Kendra?
Yeah, so I mean, we talk to our customers a lot, right? And so our customers kept telling us that their search applications could not come up with good search results when searching documents. And after years of trying different solutions and vendors, enterprises are still challenged today with two main problems around enterprise search. The first one is low search accuracy, as we mentioned earlier. And the problem there is that 80% of the enterprise data today is unstructured. Again, that's your PDFs, your Word documents, your HTML files, basically any document or record that contains textual information. And on top of that, many of the open source and commercial solutions out there are built on keyword engines that are really not fit to find precise answers in documents. They're great for some specialized applications, but they're not designed to understand context and the subtleties of human language. So that's one aspect. The second challenge is that enterprises are facing is the complexity involved in implementing search. So to connect all the data silos to make them searchable from a single place is a really big challenge. Every repository type like SharePoint, Salesforce, or even S3 has its own special set of rules to govern the documents and metadata stored in them. It's like their own little universes. So how do you create a unified and seamless experience out of so much diversity? Well, that's the second challenge we're addressing with Kendra.
So I think we're all sort of accustomed to, over time, learning how to craft the queries we ask search engines, typically based on the results we get. And I think that if we took things we search in a search engine verbatim and said them to someone that's around us, they'd look at us like we were crazy. And so, this has been a sort of a very long, ongoing process for us to learn how to ask questions to search engines. We mentioned, or at least you mentioned here, that Kendra enables us to ask more naturally. Could we walk through some examples of what those natural queries look like?
Sure. So there's many variations or many scenarios and situations and use cases, right? It's about making that experience more intuitive. So say you're an employee and you're planning your upcoming maternity leave, and you want to ask a question: how long is maternity leave, right? And instead of returning a long list of documents where you have to dig through, Kendra will just give you 14 weeks or whatever the duration is at your company, right? Or if you're a new employee and you're having issues with your VPN, you can ask a more descriptive question: how do I configure my VPN? Now the answer is slightly longer, and you'll get a very specific passage describing that task, right? How about where is the IT support desk, right? And again, you get first floor instead of a long list of documents. So you can also ask keyword queries, of course, like health benefits, right? If you just want general information, or parking allowance, that's still possible, of course. And for those examples, you'll still get these sections pulled out of documents to help you get to your answer much faster.
Well, I feel like, JP, we're skipping over the step where instead of using Kendra, we could have everybody talk in query keywords, right? So instead of asking, what do you want to get for lunch? I could say, lunch options what?
Question mark.
Ambiguity, yeah, exactly.
So, yeah, indexing and searching for information is not something that I think few people do. It's something we all have to do in some way, shape, or form. But I'm trying to think here now, Kendra as a service, who should really be looking towards Kendra to solve their problems? Who are going to be the users in terms of implementing or consuming from Kendra? Can we talk a little bit about that?
Yeah, so Kendra simplifies the implementation of enterprise search to empower both technical and business decision makers to get started quickly without installing any packages, without configuring any servers or writing any code. Kendra is a fully managed service in AWS, like I mentioned earlier. You just point Kendra at your data sources, and you can have your SharePoint or S3 data searchable in the console within minutes. That was really important for us. We wanted to simplify the aggregation process, getting started quickly.
So what was that? I mean, it's very easy to get started. What are the kind of setup steps? Can you walk us through that?
Yeah.
When I want to point Kendra at some of these data sources?
Yeah, so basically, so to get started with Kendra, right? So you have, and I'm going to show you how you set up a data source in the demo. But basically, how do you get started with Kendra is that we have two editions. We recently launched the Kendra Developer Edition, but basically we have the Kendra Enterprise Edition that provides high availability and runs on 3 availability zones and is designed for production workloads. The second edition we just launched is the Kendra Developer Edition. It provides developers with a lower cost option to build a proof of concept and experiment with Kendra. This edition also has a free tier that includes 750 hours of free usage for the first 30 days. So it's a great option to get started with Kendra. And setting up any one of these 2 editions is really simple. You just go to aws.amazon.com/Kendra and you can get started right away.
So
yeah, and I think you added the question is that what does it look like? Was that your question, I guess?
Well, I think you mentioned demo, and so it sounds like you're going to cover that in demo. So we can hold off. I think there's some other questions. It sounds like Nick had one right now.
Yeah, I mean, I was just going to say, I sort of the pie in the sky pitch in the beginning of being able to ask natural queries directly in some sort of search bar, I'd imagine, is a very clear sort of user experience. But, on the other side of things, indexing, you mentioned, is one of the large problems here. So how do you set up indexing data from all these various sources using Kendra?
Yeah, so basically we have a series of connectors. One of the key things for us was to make sure the aggregation of content was very straightforward and that everything was integrated and available in the console. So you could quickly access it, configure it, and get your data in. So we launched Kendra with 6 connectors that are native in the console today, and we have plans for other ones. So basically you go in the console and you configure your connectors, you point them to your sources, and you schedule them, and they start bringing data in, and it becomes available as soon as it comes into Kendra.
And can you share some of those data sources? What are those data sources?
Yeah, so we have, we launched 6 data sources, S3, RDS databases like MySQL and Postgres. We have SharePoint Online, ServiceNow, Salesforce, and OneDrive. And we'll be releasing many more in the next few months to cover Confluence, for example, SharePoint On-Prem, Google Drive, and others. And again,
those are some of the most common kind of document storage solutions that enterprises use that you're trying to cover first, right?
Yeah, exactly. We're talking to our customers again to see, what are those most prominent data sources they want to get their knowledge from, and that's how we prioritize the development on our side.
Now, from that list, though, RDS kind of stands out because RDS, for those of you who don't know, this is our relational database service, and this is basically just a hosted SQL server with various kinds of SQL engines backing it. And there I can kind of define my own schema. I can store whatever data I want according to that schema. So what kinds of constraints are there when you're consuming data from a dynamic data source like RDS?
Yeah, so that's a good example. So, and RDS is not a special case. You have different schemas from different repositories as well. So there isn't really a constraint in Kendra. Our connectors are flexible, and we wanted to make sure that was the case when we designed them. But we put special attention when designing the connectors to ensure customers always had an option to get started quickly with default configurations and schemas, right? This allows them to get their data indexed into Kendra quickly, and that works great for POCs and quick experiments on data sources, right? So we want to make sure there was an easy path to get started there. And if further fine-tuning is required, we provide lots of easy-to-use options for customizing the index schema, normalizing and merging the fields you want to bring from multiple data sources, because a lot of times when you're creating that unified experience, you want to map these fields from these various data sources into common ones in the index. And we provide those tools in a very easy user experience in the console. And of course, the connectors, you can refine the choice of documents you want indexed as well. So there's a lot of flexibility there, but there's also a quick start path for your first experience in the connector.
And for each of these connectors, let's say I choose one of these connectors and I want to integrate it with OneDrive. How much technical knowledge do I need in order to configure one of these connectors?
It really doesn't require a lot of technical knowledge. Again, we wanted to start by offering, out-of-the-box mapping, so you don't have to actually customize anything. But of course, if somebody has, let's say, a Salesforce repository or a ServiceNow repository, and they want to be very specific with what they want to extract from it, usually those administrators of those data sources are somewhat familiar with those data sources already. So they'll find the familiar things and objects in the connector to be able to customize that in an intuitive way. So for OneDrive, it's very simple. You just point it to your source. You can just let it pull all the content from the users that you have there. And then you can go back and iterate or refine the criteria by which you want to pull the content from there.
So, okay, I'm bought into the idea that I can easily load my data. These connectors work really seamlessly for me, and I know they'll be performant because they're built in-house by AWS to ingest this data into Kendra. When I think of anything that's powered by machine learning, I always think, okay, well, there's a training phase and there's an inference phase. And here, if it's performing machine learning powered results, that's the inference. Does the training have to happen on my sort of data? Every organization has their own data sources, their own subject matters. Does Kendra actually have to have this training phase for my data before it can start serving me search results?
It doesn't, actually. And as I mentioned earlier, Kendra does not require any machine learning expertise. That was really the tenets for designing it. We did the heavy lifting already by pre-training Kendra in 14 domains, including IT, HR, pharma, financial services, energy, industrials, and we're doing more work to actually improve those models so that you can get an out-of-the-box experience that's very, very effective. So Kendra can perform very well out of the box. Now, having said this, we are building some exciting functionality for Kendra to further improve its accuracy. And one of these pieces is called incremental learning. And when we roll it out later this year, Kendra will capture the user search behavior. So it'll actually look at what users are searching, what they're clicking on, what they're opening, their thumbs up and down. All of that feedback will be automatically fed back into the engine to update the machine learning engine and keep its accuracy optimized over time. And the second component that we're hearing a lot from our customers is also being able to inject very custom, very specific vocabulary in there or synonyms, so that so they can expand Kendra's understanding of a specific domain or business context. So, for example, if you're a pharmaceutical company and you have a particular chemical compound that's also referred to as a particular product that you're developing, then customers will be able to provide this data, typically via synonyms, for knowledge expansion.
One of the questions for Twitch chat from Werner G was also around sort of this use of historical data to improve the model over time or improve the search results. So as I understand correctly, this sort of live feedback as folks use Kendra will be usable to improve those results over time. Is there any way to ingest previous search history, or is that really not something that's available here on launch?
So today, the incremental learning feature is not available. This is something that we are designing for something we'll launch a little later this year. So we will consider all sources of signals, right? Mm-hmm. Whether it's past logs, search history that may be captured in the existing system, and feed that into the models to prime the pump, if you will, on the models, and just kind of come out with a pre-trained experience. So we're still assessing, what are the things that we can do to make it come out of the gate with the highest accuracy, if that history exists. But the sure thing is that over time, the machine learning models will continuously receive these signals to stay up to date on relevance.
So I just wanted to revisit the line of questioning we had earlier. With all these data connectors, there's the source of the data, and then there's where that data lives, right? Mm-hmm. What if I have a number of on-prem data sources? How does the integration work there?
Yeah, so I mean, as you know, in the enterprise, knowledge is everywhere, right? I mean, we have stuff even on laptops, right? I mean, it's just we talk to customers, and it's knowledge is everywhere. So we recognize this fact, and it's the reality of enterprise knowledge. So the data, since it doesn't live necessarily in a uniform and easy reachable places, in fact, it's rarely a simple landscape in the enterprise. So we actually are building what our customers tell us they need. And so we're building both cloud and on-premise connectors to popular data sources like Confluence. And that's going to be cloud and on-prem. SharePoint, for example, we have the SharePoint Online connector today, but we're also going to look at the on-prem version. Same for file systems, websites. So we want to make sure that customers, that we build what our customers need to tap into those knowledge areas. And some of these connectors are available today, like I said. Others will come later this year. So we really feel strongly about this, right? Because by covering both cloud and on-prem use cases, this will allow customers to reach and aggregate more pockets of knowledge in the enterprise and tap into all of their knowledge capital.
All right, well, anytime someone tells me it's easy to do something like setting up Kendra, I'm going to ask them that, I'm going to tell them actions speak louder than words. So I'm going to hold you to that. Is there any chance we'll be able to see you setting up Kendra for everyone at home? Because I know that's probably the first step for all of them to actually be able to use it.
Yeah, actually, I have a little demo here that I want to show you guys and the audience. So let me see here if I can share my screen. And before I share my screen, I'm just going to actually describe here a little bit, some context on the demo. So I thought it'd be fun to actually do a side-by-side comparison between traditional search experience on a website with the Kendra experience, right? So the data set I chose for this is from our own retail website, amazon.com/help, which is basically a search box for retail customers to find public information about Kindle products, Echo devices, Prime services, and other Amazon products and services. And before we look at search there, we're going to look at how you can actually ingest data very quickly with Kendra. So share my screen. So this is the Kendra console, and basically the interface takes me to a place where I've created an index. And basically, to get started with Kendra, there's this 3-step process. You first, number one, as shown here, you create an index, and that's basically a container to define the scope of the documents and the search that you want to perform over your content. So the first step was to create an index, and I already did that, and I provisioned all of the infrastructure that I need to do that without having to manage anything. So this was done as a step one. Now my second step is to actually add a data source. This is where you actually connect your index to your data sources like S3, SharePoint, etc., to bring the content and make it searchable. So I'm going to show you here for this particular demo, we talked about those help pages, right, that were on the website. So I've copied those into an S3 bucket already. So I'm just going to say, add a data source here. And this brings me to my list of connectors that are available to me. And we mentioned these before: RDS, Amazon S3, OneDrive, SharePoint. So since my content is in S3 bucket, I'm just going to choose S3 and add a connector to S3. And here, very simply, I can just type my S3 help pages. That's just the name for the data source, right? Just so I can identify it and know what's in there. I'm going to skip the description for now. Just click on next. And here I can tell the connector where my data is. So I can actually browse my S3 buckets. It tells me, it lists here the S3 buckets that I have access to. And I've already copied my pages in this bucket. So I'm just going to choose that one. Right? And if I had any additional metadata, I can always point the connector to the metadata folder as well, and it'll associate that metadata with the content. But I can actually get started very quickly without it. So I'm just going to continue here. And then I'm going to associate a particular IAM role, which I've already created in the past for accessing this data. Or if you don't have one, you can Kendra can create one automatically for you very quickly here. But I'm just going to use this one that I have. And then the last step here is to actually set the schedule at which you want the connector to run. So, it'll run automatically to sync the data. And I could say, well, let's make it run daily, right? And you can set the time, and then, it takes you to the last final page where you review your configuration and your settings, and you're pretty much done, right? You create the data source. I'm not going to create it now because there's a lot of content, and I've already, for the interest of this demo, it's already pre-indexed. It's ready to go for our searches. But basically, you're done creating your data source. And the next step after this is that the connector is going to pick up that content automatically and keep the index in sync with that repository every hour by scanning it every hour.
Hold on,
and that's
before you put that button, can you tell us a little bit about that schedule at the bottom? What are we seeing there?
Yeah, so this is the last step that I covered earlier. Basically, it's going to run at this particular time on a daily basis. So that's basically the schedule that you set in the previous page, right?
Is that configurable?
It is. So let me see here. We went back, configure settings. So down here, this is basically the schedule that you configure at which you want to run the connector. If I want to say daily, hourly, or weekly, right? So the connector basically is going to connect to the data source and sync the data there with the index. So it's going to pull all the new documents, all the deleted documents, or any modified documents. It's going to connect the data source and keep the index up to date. So that's the schedule. And it's configurable, it's totally configurable, right? You can make it start at any time you want, right? And at whatever frequency that works for you. And if you want to run this manually, you can just say run on demand. And you can basically just kind of tell it when you want it to run. If you want it to run, during your POC, you may want to run this manually, and then you schedule it to, the most convenient time that works for you.
Out of curiosity, is there any sort of estimate on the time for that sync? I'd imagine it doesn't include downtime, but approximately how long should folks expect to see those updates occurring once it triggers the sync?
Yeah, so it depends on the data source, right? Some data sources are, like SharePoint and ServiceNow. Those data sources have their throttling or their limits at which, content can be pulled from. But repositories like S3 or databases can go much faster, right? And so, and it depends on the amount of documents you have in there. So it varies. And it really depends on the document size and the repository type you're pulling the data from. So, you could get, 100,000 documents in, maybe 10, 20 minutes, maybe faster, maybe slower, depending on, again, the limitations of the data source.
Yeah, good to know. Sorry, we're holding up the demo here.
Yeah, no worries. So that's it, right? We just kind of reviewed the setup here. We set the schedule, and then the last step was just to create the data source, and it starts pulling content, and that's it. As soon as it's synced and it pulled the content, it's searchable. So now let's go to the search page because I want to show you the search experience. So we've indexed our help pages, and let's try some pages here, some queries. So let's say I'm a Amazon customer. I bought a Kindle book and I want to return it. I want to know what the process for returning that book is. So I can just type return Kindle book. And the experience you get here is that you have a card that gets presented to you at the top here, which is basically looking at the content of every document and pulling the most relevant passage where it feels the answer is, the most confident answer is, and it bolds the elements of interest. So I can see, like, to return an illegible Kindle book, I get the process, the steps, go to the manage content devices, from there, the content tab, etc. So it gives me a process, right? It's pretty relevant. I'm done with my search, or I can go to the web page and get more information about that. But I get a lot of information just by looking at that box. Okay, so that's kind of a simple keyword example. Let's say now I bought a real hardcover book and I want to return it, but I'm wondering how much Amazon is going to refund for postage. So I can get a more precise question and say, how much for postage refund? And again, I get Amazon's Kendra suggested answer at the top, which extracts these passages, very precise sections from documents. And I can see right away that the refund up to $20 is coming back in my search results. So it's very specific, right? I mean, I'm done with my search here. This is the answer I'm looking for. And let's compare the experience with, let's say, the website. So just to have the same question, I'm just going to copy this query, and I'm just going to drop it in the amazon.com/help, which basically takes you to this page. And I'm going to type in the same question. Okay, and what I get back is a list of results. It seems pretty relevant. I have returns and refunds, but I need to click here because there's no answer yet in this page, in this results page. Okay, I click on that, and I'm basically navigating now the help pages, right? I still don't have an answer. And I'll skip the process of digging into these documents and scanning, but it turns out that the answer is actually buried in this particular document about our return policies. So when I open this document, I still have to read, right, and try to figure out where is that amount, how much am I going to get back from Amazon? And okay, right here, right, it will automatically refund up to $20. So it's this exact same answer that Kendra brought. The difference is that Kendra brought it back instantly after clicking on that search button. Right. So let's cover another example here. For example, let's say I happen to have bought that book that I'm returning. I bought it with my Prime card rewards points, right? And I'm wondering, okay, well, I'm going to get refunded, but how long does it take to get those points back into my account? So I can say, how long to refund points? And here it extracted a precise, very, very narrow answer within 24 hours from this passage that was found from this document that I've indexed, and I'm done. My search is done. I'm not going into documents. I'm not scanning for anything. This is the end of my search. Very precise, right? Now, my last example here on points is, for example, I'm wondering, okay, I'm going to get those points back, but do my points ever expire? So I can ask the question, do my reward points expire? And again, I get my Kendra suggested answer at the top here that pulls out that specific section, and it bolds the answer. Points do not expire as long as you are a card holder. So it understood the question, and it bolded the element that would be my answer precisely there in this section. So this passage and the highlighted answer were spot on. So this shows you Kendra's ability to perform out of the box really well for this particular use case, which happens to be, customer service and self-serve pages on a website. I want to show you another example here. This is a project we recently launched to help accelerate research on COVID-19 for the scientific community. And so here we indexed the publicly available COVID-19 dataset, which basically contains over 40,000 highly technical articles from leading scientists and institutions about COVID-19. And the search tool is powered by Kendra and offers the same natural language understanding capabilities to find very precise answers without any prior training on the dataset. So let's see how Kendra performs in this particular scenario. Let's actually try some queries here. Okay, so let's say, okay, I'm searching all of this COVID-19 stuff, right? So I might start with a simple question like, where did COVID-19 start? To see if it finds a location for me. Okay, it brought back this particular passage and it highlighted a location, the Hubei province in China, from this document, right? So this is spot on. I have my answer. That's great. What if I say, okay, this is finding a location. What about a time frame? So what about a time? So when did COVID-19 start? And right here, it extracted December 19, again, from this passage, from this document in the data set. So again, very precise. Let's keep trying something maybe a little more technical. Let's ask it, let's see, what's the incubation time for COVID-19? What's the incubation time for COVID-19? Okay, and it tells me 5 to 6 days. Same situation. I'm asking different kinds of questions, right? I'm asking about locations, I'm asking about durations. I'm asking about timeframes. And another example could be, let's say, I'm wondering about how long does the virus last or live on different surfaces, which is something that has been circulating around. So I might ask, how long COVID-19 on plastic? And again, these questions, the grammar is not perfect. I just want to go quickly, but give it enough context to be able to find an answer. So how long COVID-19 on plastic? And again, it actually extracted the exact answer for me up to 72 hours from this document here. So that's it. That wraps up my second demo showing Kendra perform in a very different domain, a scientific domain, highly technical context, out of the box, no training on this data set. So it gives you an idea of how you can deploy Kendra in a multitude of use cases and contexts and be able to perform really well out of the box. And we don't have time today to cover the relevance tuning options that we have that are very intuitive, but there's a lot of easy to use options in Kendra to further refine and fine tune these, its relevance algorithms.
Yeah, that is very cool. The ability to kind of go in there and type in natural language what you're searching for, and the ability for Kendra to find those high quality matches is very impressive.
Mm-hmm. Yeah, I think what jumps out to me is in the search for an answer to a query or a piece of information, we start with sort of like our question in natural language in our head, and you showed sort of the default status quo of the path, right? It's like a search engine may return a document, and then you need to open the document, you have to find the passage that may contain the information, and then you have to parse that to see if it has it. But what Kendra's doing here is it tries to abstract away as many of those steps as possible to the point where from a natural language query, hopefully it could give us a direct answer. We see here on the screen up to 72 hours for this question. But even if it can't, confidently return that, it's doing things like pulling out relevant passages. It's going another step further and highlighting specific key phrases that are very likely to have relevant information to your answer, so that your time from, question in your head or query to actual answer is minimized as much as possible.
That's exactly right. That's the objective, right? Is to minimize the time from the question to the answer. So when Kendra is very, very confident, you'll see it up here at the top. And when it feels that it requires a little more context, then it'll show that passage, which still provides your answer right there. You're done with your search. It just provides a little more context for you to read around it and get more confidence on the answer. So in both cases, your search stops right there on your search results.
Wonderful. Are there any customers that are using this in the wild? I mean, we showed, some examples of how easy it is to set up. We showed what it looks like with, that data set for COVID-19. Are there any organizations that are using Kendra successfully right now?
Yeah, so some of the examples, PwC, for example, has a product called Reg Ranger, and it's a service offering they have for regulatory compliance. And their goal is to help their customers get to the answers they need faster. And even when the answer may be buried in documents that are 100 pages long, right? So they have these really, really long documents. And just obviously, even if you have a search engine on top of that, that would give you a match. It tells you, okay, the answer is in the document, but now you got to go through 100 pages to find where the answer is. So here, it's really important for them to get to that passage, to get to that needle in the haystack, basically, to go faster, right? So this is important because they want to make sure their clients understand regulatory information faster and make decisions more quickly and confidently, right? So as an early Kendra adopter, PwC is now developing and testing enhanced search capabilities for their next version of Reg Ranger that will allow users to ask natural language questions. And this is a dramatic improvement over the traditional keyword searching methods and manual reviews of documents they've been doing so far. Another example is 3M, which is similar to this COVID-19 demo that I showed you. At 3M, it's all about accelerating material science research, right? With over 8,000 material scientists and 1,200 new projects every year, 3M needs access to information from prior relevant research, information that's buried in many patents they hold in their huge knowledge base. They've been doing this for years, right? So Kendra lets their scientists find the information they need by handling natural language queries quickly and accurately, allowing them to innovate faster, collaborate more effectively, and accelerate the ongoing stream of unique products for their customers. So imagine being able to get the same kinds of answers that we just saw here today on COVID-19, but on a different set of technical documents. So this is really key for research.
As someone who many moons ago did a lot of scientific research, I can only imagine how valuable it would be to search like a reagent name and be able to come up with an exact passage from a standard operating procedure to know exactly what you need to do instead of having to find the paper, dig through those. Those are maybe not 100 pages long, but something in that order of magnitude. They're very dense. A lot of friction there. I'm really excited to see 3M using Kendra to solve that pain point.
Yeah, and it's not just about speeding up the process of finding the information. It's about liability as well, right? When you cannot find the information that you're looking for, or when your employees cannot find the right SOP or standard operating procedure, it's a liability problem, or it can be, right? So there's a lot of consequences for having low accuracy search in the enterprise. Another customer is Baker Tilly. They're a large consulting services company offering accounting and financial advisory. And they work very closely with their customers to give them insights on market conditions, customer preference and trends. And with Kendra, they reported that their clients were able to service relevant information 10 times faster than with their SharePoint search. So for example, Amazon Kendra allowed their product managers to ask questions in everyday language, such as what parts are made out of titanium, and quickly surface an answer or a list of relevant product manuals, technical bulletins, service alerts, and patent registrations, something that was previously not possible with their keyword search solutions they were using in the past. So that's a really encouraging use of the technology, and we're super excited to work with them. And the last example I have here, and we have other customers in our customer reference list on the website, but this was interesting also because WorkGrid is a wholly owned subsidiary of Liberty Mutual, and they developed a platform to quickly implement chatbot applications that allow employees to get quick answers to frequent asked questions and automate tasks using friendly natural language interface. And one of the key things about enterprise chatbot is the ability, or one of the key challenges I would say, is the ability to answer the myriad of questions that come from employees. But that can get really challenging very quickly because chatbots are trained on predefined intents. So how do you anticipate all of the variety of questions you can get? But now with Amazon Kendra, it makes it possible to extract answers directly from unstructured data across multiple repositories. So we're super excited to work with WorkGrid to explore Kendra's natural language capabilities to enhance their chatbot platform.
Yeah, awesome. So just wanted to reiterate what we're announcing today. Well, this Kendra GA'd a few days ago, right?
Correct. Yeah, we launched on.
Customers can start using this thing today.
Yes, it's readily available. They just go to aws.amazon.com/Kendra, and again, they have those 2 editions available there, and they can get started today.
That's wonderful. What regions is it available in?
It's available on US East, US West, and Dublin.
Okay.
And we'll have plans to expand to many more regions later this year.
We had a question in chat actually about whether it recognizes voice input or if it's possible to write an app that embeds it into Alexa, for example. And I think you mentioned before that text is the only input for Kendra right now, but I can imagine that it would be not too difficult to take either Amazon Transcribe or some of the existing tech in Alexa to sort of convert that vocal input to text and then query Kendra directly with that, right?
Absolutely. Kendra is really, you can, it's offered as an API as well, right? So you can build an application to either take input from a web, search box on a web page, or it could be a chatbot application, or it could be taken from an Alexa scale, for example, right, where the input is actually voice. As long as you're sending us the utterance from the end user, we can perform the search and send it back to you. And you can convert that back to voice with the other tools that we offer in the AWS services.
Wonderful. Well, Rob was hinting at it before, but Kendra now generally available. I see 3 regions here: US East, US West, and Dublin, with 7 more by end of year. Does that sound about right,
That's
JP?
correct. That's correct. Yes.
Awesome. Very exciting. Very, very rapid expansion for service availability. But without further ado, JP, thank you again for the time. The demo was wonderful. Again, in just a few moments, we saw how easy it is to set up from scratch, integrate with one of the provided data sources, in this case, Amazon S3, amongst the many that we have first-party data connectors for. And then we saw it in action, getting to see some of those natural language queries, speak like a human and not have to reverse engineer how we need to ask the system to provide us the data that we need. So again, JP, thank you for the demo. We will be going to a very quick break yet again, but then we will be right back to close out the show and with some closing remarks. Thank you again. See you very, very soon.
Thank you.
Folks, if you're making it through here to the end, we've been streaming for a little over 2 hours now, almost 2.5 hours, but that's for good reason. We've had a lot of very exciting launches that we want to be able to cover here, and we've gone through quite a few today, actually. This is a record, first episode covering 4 launches. We had so many demos we wanted to show, we actually cut out one of the sections in the beginning, which I know everyone wants to hear more of Rob and I talking, but we think surfacing more of the demos is one of the more important things we can do on this show.
Yeah, definitely been one of the more information-packed episodes. Thanks to everybody who stuck through. It's a lot of information, but I was excited the whole way through. I hope you were as well. Nick, now that we've seen all the demos, can you go through what was most exciting to you? What really jumped out at you?
Yeah, so I knew coming in I was really excited about A2I, Amazon Augmented AI, because I'm an ML geek. I help to build AI systems, and this solves a problem that I know everybody has been facing and there has not been a good solution for. But actually, over the course of the broadcast, I was probably most impressed by Graviton 2, M6G instances. I think after you sort of put it into perspective, saying that all of these other fundamental services built on top of EC2 at AWS will benefit from this. It's not even just a small percentage, single-digit percent increase. This is orders of magnitude, like 20 to 40% in some workloads. So I'm really excited to see this, and especially our own custom hardware, our own chips with Graviton 2 with Annapurna Labs. That's extremely exciting, extremely groundbreaking. It felt like that was way more than just one launch, right? Like our first 6th gen instance class too, right? That one really sort of blew my socks off. But again, 4 very, very exciting launches.
Yeah, definitely. The Graviton 2 launch is going to be huge, and I can't wait to go and spin a couple instances and play around with it myself. You hit the nail on the head. This is going to create so many downstream benefits across all number of AWS services. Even if you don't use Graviton 2 directly, you're going to benefit from cost savings coming down the road. And this is something that we're constantly doing at AWS to try to deliver better cost structures to customers. And the other thing is that we keep going back to this custom chip thing. It's really not an easy thing. I mean, could you imagine starting a project and going, yeah, all right, here's the costing document, and the first thing we're going to need to do is design a custom chip, right? We need a new login form. Step one, design a custom chip. It doesn't work like that, right? But at AWS, what we have is we have so many workloads across so many industries that making this kind of investment for us is a no-brainer, and we're continuously doing it. This isn't even our first custom chip. And so you can see that this is the kind of innovation at scale that we refer to in a lot of our talks at reInvent. This is the kind of investment that we're constantly making to improve these cost structures and deliver better performance, lower price for all of our services. So it's just really exciting to see that all come together. But I don't want to shortchange any of the other demos. This is really an action-packed line. Probably my favorite episode so far. It's been an absolute treat just kind of seeing all of the demos really kind of back to back. But I want to bring it back to one of the segments that we do at the end of the show for the past 3 episodes, which is that we like to play this game where we string together all the announcements into one imaginary service. How exactly would we make Graviton, Glue, A2I, and Kendra work together? Nick, you want to take a first stab at that?
Oh man, okay. Kicking things off here. So we have a Graviton 2, obviously, or the M6G, new instance type. Glue Streaming ETL, A2I. So, all right, I'm thinking we've got some sort of data-driven workload here where I don't know how we're going to ingest the data, but we're going to have some sort of streaming data source that will power a machine learning model in the middle, and then we'll have to fit into A2I. So let's say, let me think. Let's say we have a streaming ETL solution for video data that's coming in. Maybe we're monitoring this broadcast, right? And every single time, I don't know, like a dog walks across behind me, which will have to be fronted, which will be predicted by a machine learning model. It doesn't matter where it is, right? It could be SageMaker, it could be whatever. But that video feed, those frames where recognition is detecting whether it thinks there's a dog there, those will get fed into A2I. And if it's not too confident, it'll feed those to a human reviewer who's sitting on standby to review if there's a dog that's walking across the frame. All right, back to you.
Oh, crap. I thought you were going to take this the whole way.
We'll go back and forth.
Okay. Yeah. So I think you're in the right ballpark. I'm just going to riff off of that. It has to be kind of document-based streaming data. So I'm thinking maybe, how about a tax prep software? And what we can do is use Kendra to kind of organize all the IRS documents to make answers kind of readily available with natural language processing based search. And then as these documents are submitted during tax season, let's say, that's all coming through with ETL streaming via Glue. And these documents can kind of, we can basically run these different transform jobs, extracting various different pieces of data and storing them into a data lake somewhere. And in the process, what we can do is we can run the augmented AI solution on top of that and say like, well, okay, hold on, this document is a little bit abnormal, right? It's missing this field, but it has these amended documents. Can our AI system figure out just what's going on here? And if not, flag a human down, and then they can kind of go through and fill that data out. And then if something's really missing and we need to do some processing, some heavyweight work, maybe some compression to sort somewhere, we can send that off to a Graviton instance, and it can do that more quickly, more cheaply.
Yeah, I actually like the approach you took a little bit better. I think it ties everything together a bit more cleanly than mine did. But essentially, let's say, like you said, a tax processing software or form processing software, document processing software comes in over Glue Streaming ETL as data, like let's say like it's real time, right? Like as you're filling out on a tablet, you can actually get that data being streamed over Glue ETL and processed. That could be sent over to Textract, and then that's going to hit our A2I endpoint. It's searchable. Maybe those results are searchable via Kendra to the internal side of the company, or maybe some of the result, like the information for how to fill it out, is searchable via Kendra. And then we have Graviton 2 could maybe host our web app, right, at extremely reduced cost savings. We could maybe host like Memcached on it to be able to more quickly serve those cached results to customers. So yeah, there we go. I think that hits the pass for stringing all 4 of these very different launches together. But
this is by far the most stressful segment of the show, by the way. It's like being put on the spot and say, hey, look, here's the secret ingredients for everything, toss it together in 30 seconds and come up with something semi-plausible. But I mean, I think that now that we're talking about it, it would be a very interesting idea, right? Kind of the demo that JP showed us where, we basically took a whole bunch of COVID-related documents and we pointed Kendra at them, and we ended up with a nice tool that people can go and search through and find really common answers to. I mean, what if we did that with all the IRS documents? What if we did that with, any document database that has really complicated rules and interconnections between them? I feel like Kendra kind of really shines in that space.
Yeah, I'd be really curious to see. I know like tax forms and understanding how to fill out certain sections are a really hard problem. I'd be curious how much value would be provided of just literally taking the tax like the formal government tax sort of guidance and putting that into Kendra and seeing how effectively it could answer people's questions.
Yeah. Or how about taking the Kendra suggested answer and then feeding it back via a chat bot, and the customer says that's not good enough, then trigger A2I.
I feel like we're getting in dangerous territory where I'm about to just like do Twitch plays, fill out my taxes. And
I feel like if we keep going, we're gonna be like, all right, we're quitting our day jobs, we're building this tax startup, and we're gonna use Kendra, and we're gonna
we'll pitch that show, right? All of these ridiculous ideas we take at the end of the show, and we have to actually build them live. But that's for another time. I know some people in chat are excited for that idea, but we've already been live for 2.5 hours, so I don't know how much longer we can go on. We need food and water. Unfortunately, we can't sustain ourselves on the joy of AWS service launches. But yeah, again, this is episode 4 of AWS What's Next Live. Thank you again for tuning in. We're co-streaming to both Twitch on the twitch.tv/AWS channel, as well as LinkedIn Live. So if you've tuned in either recently or you've been here for the whole broadcast, thank you. We're happy to always get your questions answered. We're also looking into distributing this show on a few other platforms as well. We're interested in maybe cutting out the audio and making that available as a podcast. Some of these sections will be redistributed on some of the service pages and available both as VODs here on Twitch, on our LinkedIn page, as well as potentially on YouTube. So yeah, again, if you have any feedback, please get that sent over to us. I believe we have some links in the chat for surveys. They come with some some AWS credits to thank you for your time. But again, this is our faster than monthly cadence show. Most importantly, our next episode is going to be June 5th, I believe. Is that right, Rob?
Yes, that looks like the next episode our date.
Cool. Yeah, running on about a 3-week cadence. So that is going to about do it from us today. We had a blast. We hope you did as well. And again, a huge thanks to all the service team members who took the time to join and showcase all of the exciting demos. But with that, we are done for today. There are many demos that we were not able to get to because there are just so many launches, but we have taken the liberty of assigning those all into a rolling credits slide to close out the show. Rob, any last words before I hit the credits?
No, that's it. Thanks for sticking with us, and hope you enjoyed the demos.
Yeah, and again, any and all updates for the show, you can follow us on Twitter. Those links are in the chat. They should also be on screen now, but without further ado, happy Friday, everyone. Have a great weekend. And that's closing and signing out from episode 4 of AWS What's Next. See ya, everyone.